If you want to start. Okay. Hello, everyone. Good evening. This event, I'm from Just Eat, by the way. Just to give you a bit of a kind of a bit of information about the event and about the place where we are. This event is recorded, but it's only the slides and the voice that is going to be recorded. We have got a microphone over there for questions after the event, and in case of emergency, if you hear an alarm going off, the emergency exit is around the back of the lifts. There is a staircase which would lead you downstairs and outside. Don't take the lifts. Toilets are at the same in the same direction around the back there of the lifts in case you need them. That's pretty much it. The event is hosted by Just Eat, but we really love to have LondonJS every time. And Luca is from LondonJS. He would probably say a couple of words about the event tonight and the speaker, and I'll leave you to it. Enjoy.
Thank you very much. Thank you for having us first. This is always good being here. Okay, hi guys. So we're about to start. I hope that you will enjoy the event. I think tonight we have a super interesting topic. So JavaScript testing that I think overall is always great to hear talking about that, because all our code should be properly tested, obviously, and in particular it should be solid enough. So tonight we will have a great talk, so I leave it to you and enjoy the presentation.
So thank you for having this opportunity to talk to you guys and tell about my experience with testing and JavaScript testing in particular at Nested. So first of all, a little bit about myself. I'm a father of two sons. I went from business to software engineering. And the reason I've put these two facts up here is that I have been coding for less than 2 years. So I needed to come up with something that would convince you that I'm like a serious person and I know my stuff. So like being a father makes you look like serious and you know what you're talking about, right? Thank you, I suppose. So yeah, that's me. And let's get started. So what will I talk about? I'll talk about all kinds of tests, including painful tests, integration tests, and unit tests, and snapshot tests, end-to-end and visual regression tests. So we have a lot of ways to test our applications nowadays, and I think each and every way is slightly different and useful in its own way. So we have to have a good understanding which way do we want to go for our test, and have a good understanding as to what do we actually want to test with each thing. So a quick show of hands, who of you think that JavaScript testing is painful? Raise your hand. Great. And now leave your hand up if you have written more than 1,000 JavaScript tests. Okay, so there's a couple of people left who have written a lot of tests and still think that JavaScript testing is painful. And I guess I'd still be one of those guys as well. It's just, yeah, it's difficult because as a community, we still don't really have a good way of, or one way of testing things, and there's a lot of different competing ways how we should like test our applications. So I'll talk about this a little bit more later. So to get started, I want to get us all on the same page. So what are automated tests? Just want to show something that is a test. So we have a very simple function here. We want to check that an argument that's provided a function is defined, is not null, and is not an empty string. And we have unit tests for it. So the unit tests are very simple. Basically, we just take that function, call it, and expect the return value to be true or false, depending on what we provide that function. So you can see all kinds of assertions that you're making here. This is probably the unit testing that everybody starts with and sees for the first time, and this is how people think about unit tests when we talk about unit tests. So why do we need tests is the other question that you need to answer before going on to discuss different ways to test things. So first of all, personally for me, speed is very important. as a developer, it's faster for me to write a test that actually does the testing for me, rather than going to the browser and like clicking the button every time I change something, or that inserting something into the database and seeing that the insert went correctly. I'd rather have a test for that does this automatically every single time I change something, and it's just much faster. So I can develop things faster having tests, which run much faster than I can actually do something manually. The other bit is certainty. So over time, as we accumulate a lot of tests, we actually become more certain about our app and the features working as expected, because all the tests that we've written to begin with to help us develop that feature are there to later on make sure that everything's still working when we refactor things or change things or move things around. So these are the main two things for me. Why do I write tests, and why do I think others could benefit from tests as well? So what makes testing painful? In my head, there are two parts to testing. First, you need to learn how to write tests, because tests do not usually come built into like the app code. You actually need to learn about the testing framework, about like the testing language, and how do you actually write good tests. So yeah, there's no clear consensus in the community, as far as I know, as to like what's the best way to write tests, what's the best way to test one thing or the other. Like there are multiple different opinions, and this could be both good and bad in that there are different ways to do things, and people keep innovating. But for a starter, for when you are actually learning how to write tests, it's not really helpful, because you don't really know what thing should you learn and how should you do stuff. The second bit is setup that's required to get started. Like if you need to do a lot of things to get your tests running, it will be painful for you to begin with them. You need to learn about mocking, test scope, as like how do you test that one particular thing that you want, and a lot of other things. So there's a lot to learn when you begin writing tests. The second bit is you need to learn how to write good tests. So now that you've learned how to write tests, you need to actually learn what is a good test and how do you test things in a good way. I think it's the same as with a programming language. You learn how to make things first, and then you actually learn how to make things good first. So yeah, that's really important. So what are painful tests? So slow tests are really painful. If you have to wait for them for a long time, it's going to be painful. Flaky and reliable tests, again, if you have to think, if your test breaks for an unknown reason, or it's just like flaky and sometimes breaks, sometimes doesn't, it's really painful for you, because you can't really get any value out of the test, and it just like consumes effort. Tests that are hard to read and understand, again, if somebody can't read your tests and understand them easily, and we have to like think about it, then it's going to be difficult for them to get into the testing and actually like add more to it, or like change the test if it needs updating. Tests that are useless, like I've seen a lot of tests, and I've wrote myself a lot of tests that didn't really test the things that I wanted to test, or I thought that we test something and we didn't. So that has been really painful to deal with, to learn that your test didn't really test anything, and you like bang your head against the wall and saying, like, oh, I've tested this thing, and in reality you didn't. So that's annoying. And then finally, low coverage to effort ratio. So like if you spend a lot of time, if you spend one day writing a test that just like tests one small thing, you spend so much time and you aren't really gaining that much in terms of like the future time. So again, that's not cool. So these aren't the things that I came up with, by the way. Aaron Abramov, a guy from Facebook and a guy who teaches others how to write good tests, had this talk about JS. So the beginning of the talk is about testing in general. So I highly recommend watching this YouTube video. He covers these in a bit more detail, but yeah, for our purposes, it's more than enough. So the conclusion from these things for me is to iterate. A lot of these things that I've mentioned can't really be solved by tools, by just like changing your tools or adding more tools. You actually have to know as a programmer what you want to test, how do you want to test it, and you have to make sure that like you are actually testing the thing that you want to test. So it's generally up to us, and we have to continuously get better at writing tests. There's no way around this. So delightful JavaScript testing. This is my journey that I've been on at Nested for quite a while now. I want to make sure that tests are not only easy for me to write and work with, but I also want my colleagues to be able to pick them up and get on with them very easily, delightfully even. So what makes testing delightful? That is sort of obvious after the things that you've discussed already. So minimal setup, clear consensus of the best way to write, so that at your company you should have a good way. So if you want to test this, this is how you do this. If you want to like test your app in the browser, this is how you do this, and this is the tool that you use. Fast test, reliable, easy to read, understand, test that catch bugs. And finally, like the last bit is really important. I can't stress this enough. Good coverage for little effort. This will come up later, but like we write a lot more integration tests because with like a single test, you cover a lot more ground, and with very little effort, you gain a lot of value and test big parts of the application. So always think about how much value are you gaining by writing that test and adding it to your code base. So integration testing. This is the default in my head, and I think that the default for us is nested. And we write a lot more integration tests because, as I mentioned, they cover a lot more ground. And you test several parts of your code base with like very little code. So we use Jest for it. Raise your hand if you have heard about Jest or use Jest. Awesome, pretty much everybody. So Jest is nowadays, or in my head, a de facto tool to go for if you have React apps and you want to test those React apps. It's also maintained by people at Facebook, so obviously they make sure that your React apps work well. Another bit that I haven't mentioned here is Enzyme. Enzyme is made by Airbnb, and it's quite helpful, so we use Enzyme as well. So why Jest? Minimal setup to get started, clear consensus of the best way to write tests. So like they have a lot of main assertions, they have like good ways to mock things and spy things. So it's fairly easy to get started. Blazingly fast tests, that's a thing. So since Just 23, they branded themselves as blazingly fast. So if your test suite or like your test framework is not blazingly fast, you're doing something wrong now. So yeah, that's awesome, blazing fast. And custom matchers makes tests easier to read and understand. So custom matchers is one of my personal findings lately that I have been really happy to use. And yeah, I'll share them with you today and show you how they actually make life easier for both me and others who work with my tests. So what do we use integration tests for? Integration tests mostly for me and for us at Nested is used to make sure that front end and back end are properly integrated and everything else in between there. So like the whole app works well in conjunction without having to deal with the actual backend and the actual like browsers and third-party services. So we mock a lot of things. So let me show you some code now. So this is the management back component. So I'm going to show you today the real code. So I never liked examples that show you like how you could test things or how you should test things. I want to show you how we actually test things and what code do we actually write at Nested. So management back component is one of the things that I'll be showing to you today. Just want to show you what it actually looks like in practice. So this section is the management back component. It has a couple of fields which are conditional, so you'll see that in the code. But effectively, this component is responsible for this section. If you take that component out, the section just disappears, and like you can delete the folder and things will still work fine, except the section will not be there. So this is what I'll be showing to you guys. So this is the component. We use CSS grid, so don't worry too much about the grid, the leaf cell. That's mostly just positioning. We have some radio buttons as you've seen, some conditional logic in here, a couple of more fields based on one of the values being true. Again, another radio button which enables or disables the other button. So it's a fairly straightforward component. There's not too much going on in this particular component. And then we have a couple of hierarchy components. So basically, we are using Apollo, and we add a couple of queries, error boundaries. Again, don't worry too much about this. We'll cover them later. So now I'll show you how a test for that component actually looks like. So we start with the name of the component, and we say all the fields and the first test should get values from a backend. So none of the fields of that component actually store value in the state or anything like that. So Apollo handles the state management for us, and everything's like directly synced with the database. So effectively, we send a mutation and we wait for Apollo to get the value from the backend saying that everything went fine and the value has been updated to actually update stuff. Though we do use optimistic responses, but like effectively that's what happens. So let's start reading this test. So first thing that we do is we use mount with providers function. So that's a custom thing that we have written ourselves, and let's look what that looks like. So effectively, query resolvers and mutation resolvers are GraphQL specific things. Raise your hand if you have dealt with GraphQL and are familiar with GraphQL terms. Okay, not too many people. So GraphQL effectively is a query language for the front end that allows you to query data from the backend and send queries straight to the backend. And effectively, query resolvers are like get statements in your RESTful API, get requests in your RESTful APIs, whereas mutation resolvers are like post requests or like put requests in your RESTful API. So you can think about query resolvers and mutation resolvers as like as get and post put requests. Albeit they are not like directly comparable, but for the sake of this example, it will be suitable. So what we do here is mount with providers allows us to pass in some options, and then we can mock stuff about queries or like get requests and post requests that we want to be returned from a backend. So we want to mock our backend in our integration tests. We don't really want to make network requests and actually hit the database and do stuff. So we want to mock all the responses. And when we define these things, yeah, we create a schema. So if we go up top, Apollo and GraphQL provide a lot of great tools to mock your backend. So this may seem like a little bit like a pitch for GraphQL, so don't mind me too much. But effectively, it's very easy for us to mock the backend because we get our schema, which is type defs, which we use here, which comes from the backend. So with GraphQL, you have to define all of the types in the backend and all of the fields that you want to get from the backend. This allows you to get the schema very easily, which allows you to, in turn, mock your backend. So we don't really need to do any mocking ourselves. We give it to the GraphQL tools library, and they provide you all of the mock values based on the schema. So you get all of the mocks for free, and you don't have to do that much typing yourself, unless you actually want to make sure that a certain value is of a particular value. So now that's covered. We add the mocks and we add resolve functions. That doesn't matter too much. When we create the Apollo client, so effectively this is like our mock backend. We use enzyme mount, so that should be familiar to most of you because you know Jest. And then we have providers. Nope. Ooh, that didn't go well. Nice. So there's one more thing that I wanted to show beforehand. Since our GraphQL schema comes from a backend, we always want to keep it up to date. So we don't really want to store it in our code base. So what we do is before we launch tests, we check if the schema exists. If it doesn't, we actually make a request to our production server to get the latest schema. And if the schema exists, we don't want to override it. So again, this simple thing just shows how you want to make sure that somebody who's new at writing tests and who's just like starting out shouldn't really deal with getting all of the mocks or doing a lot more than just like running yarn tests. Then I don't have providers. So effectively, providers are like three things in here. So it's Apollo, it's React Router, and it's style components. So things that you are probably already used to and know what they are. We just wrap them around our component. So every component in our app, we make sure that our component is mountable by itself on the DOM if it has all of the providers available for it. So it's like it's a small app, each component being a small app. So going back to the test, now we have our wrapper. We finally covered this part. The wrapper is effectively our component mounted on JS DOM. and we passed in some custom create resolvers, so the values that you want to get from the backend, that shouldn't matter too much. And then we wait for queries to be resolved. That's one of those things that trip me up a lot, and I think it's good to share this. With Apollo and GraphQL and making requests in general, when you mount your component, the requests that change the state of your component and force the component to be re-rendered, you want to wait for those requests to finish happening before you actually do any assertions on your component. Because effectively with Enzyme, everything's synchronous, and if you don't resolve your queries, your component will be on the initial state, so on the loading state. So the way we do this is we have resolve queries helper, which is really a very simple thing. Because Apollo schema is just a promise.resolved wrapping a value, promises are immediately or synchronously resolved, but they actually go on to the next queue. So if you're familiar with JavaScript event loop, promise.resolve put things into the memory, and since they are immediately resolved, they go on to the queue and are taken up by the queue on the next tick. So if we wait for the next tick to happen, then we are sure that the promises have been resolved and our components have been re-rendered. And the second bit is wrapper.update. So with Enzyme free update, wrapper is no longer mutable, so we need to make sure that our wrapper has been updated. It's really confusing because if you call wrapper.debug, you'll get the updated version because like that just renders your component. So when you do wrapper.debug, things seem to be working fine, but like when you make your assertions, things don't work. So wrapper.update, that's really important. So yeah, and finally we get to write our test. So this is the boilerplate. This is what we need to do to mount a component and make sure that like things are working. And then we make assertions against that component. So as you've seen, that component is very simple. It's just 5 fields, and we want to make sure that every single field has a value. So we expect the wrapper, which is the mounted component, to have a field with value. So this is a new thing, and this is the thing that I really wanted to show you guys, and I'm really excited about. You won't find this in Jest's docs. This is a custom matcher that has been written by me, and effectively we have a fair few of those that help us with common tasks that we need to do. So let's look at what this thing actually does. So Jest allows you to really easily write custom matchers that do some fancy stuff. So the first argument is always the argument that is provided to the expect function, and all of the other arguments are arguments that are provided to the assertion that you are writing here. So what we used to do a lot is we used to do .find in our component to search for the field that we want, or the part of the wrapper that is particularly interesting to us, and we make sure that it's found, and then we do some other stuff. So we encapsulate this bit, and we make sure that like we can just do to have value, to have field with value, to no longer write this boilerplate on every single test. The other interesting thing, there's a lot of interesting things, at least for me here, data test attribute. So if you have heard about Cypress or you have read the best testing practices blog post, people actually recommend using data-star attributes for writing your test instead of relying on labels or values or IDs or whatever else. You should actually have something that specifically tells person writing the code or changing the code or reading the code that this particular field or value is being used in the test. So it's quite useful to have these like data test attributes that immediately tell others that this is going to be used for the test, so you don't actually accidentally break stuff when you refactor things. So yeah, now that we find our element, we check that the element exists, and if it doesn't, we can show a custom error message. Custom error message is the meat and the main thing that is, for me, really important about custom matchers. With custom error messages, you can provide a lot of guidance to people who are writing your test. So when people copy-paste something from it, they don't necessarily always understand what this thing actually does. So if it breaks, it's like, oh, what do I do now? How do I fix this thing? So with custom matchers, it's really awesome because you can give them tips and guidance as to how do you solve this problem. You can tell, okay, if this broke, try using console.log wrapper.debug. It will tell you what actually is in your component. And if it isn't there, maybe you're like not rendering this, or maybe you haven't called await resolve queries, these sort of things. So that's really useful, and I think that's the main thing why you should use custom matchers a lot more in your tests, unless like your tests are really basic. So if the element doesn't exist, we tell them element not found message and give them more guidance. I'll later on show you the sort of messages that we have. The second bit is we just like actually check if the value matches, the field has the value that we want it to have. If it doesn't, we just return that the test has passed. So this is the first custom measure. And yeah, as you see, it makes your test a lot more cleaner, because now you can just like go through all of the fields and say, I want this field to have this value. And since I've created all of the resolvers myself, I specified in the mocks that this is what I want to have. With this test, I'm covering a lot of ground. I'm covering that my GraphQL queries are actually properly wired. I'm requesting the things that I want to get. There's a lot of, like, I'm getting those things actually from the backend, and things are working fine. So with a couple of these tests, I've covered a lot of ground, and I can be reasonably sure that my component is working and getting the things that I want it to get. The second bit is also really interesting. So you've already seen the first part. Again, some boilerplate, mounting the component, giving it the values that we want the backend to return, waiting for the component to do its thing and resolve everything. And we have another custom assertion, which is called to have field with working mutation. So this is another custom assertion that has been written, and you'll see a lot more things happening in here. So we do the same thing as before. We actually try to find that thing. If we do, this thing is really important. So, oh yeah, it's here. So we actually check if the component, before we actually do any mutation, before we make any change, we check if the component has the same value that we are expecting it to have. So if you're already testing that something changes value, and that before you actually run your test, the value is already the same, your test isn't going to do anything like that. So what we want to do, and what we can do with custom measures, we can throw an error and say, hey, dude, you're already testing for something that is already there, so your test is not going to do anything. So might as well change your value and test for something so that your code actually changes something, and you actually do get the benefits of having a test that does something different. So that's really awesome. I think that's quite valuable, and this is how you can actually help and nudge and guide people to write good tests, and actually give that guidance as we are writing their test, instead of having to say on the GitHub PR, oh, are you sure that this is like testing the right value? I think you already have that value before. So it makes your life easier, and like it automates the inspection of tests and making sure that the tests actually are valuable and doing good things. Yep, let me do some like things that are specific to our implementation. So we need to have mutation and property values on there. So it's just making sure that these exist on the field. And yeah, finally we make the mutation. So we make the mutation, update the component, and check that the value has been properly updated. So with these tests, with basically 94 lines of code, I have covered a lot of ground. I've tested that my component is getting values properly from the backend. I've tested that we are properly dispatching mutation and things are being properly updated as well. So I'm reasonably sure that my component is doing everything I want it to do, and that I've tested a lot. There's like not really that much that I can test besides this, apart from a couple of things. So yeah, before we go on to the next part. So these are the sort of error messages that you would get. So this is the error message that you get when field is not found. So they say field with data test, like you need to tell you this is what you're looking for, is not found, and like the tip that I mentioned, try and do console log to see if that thing is actually there. So it's quite useful to people. And the good thing about this is that you can actually constantly update this. So as you peer with your fellow developers and you see how people actually write tests and the problems they encounter, you can like update these tips and tell them more, like actually tell them to solve the problems that they are having with your tests. So again, that's quite awesome. So the second bit that's really important is to actually have a good way to mock your backend. So we were lucky with GraphQL in that we had GraphQL tools. We haven't actually found the right solution immediately. So what we ended up doing, we've iterated through multiple ways of mocking your backend. So at first we had like manually written JSON responses that we expect the graphical request to return on a certain request. That was really painful because effectively every time we've updated something, we'd have to manually change this. Like what would happen is we'd go to the local application, copy the response that we would get and like paste it in here. As you can imagine, this was really painful, and like people started lifting their hands up after a week and like, no, we don't want to do this. So the second bit that we tried was actually recording our test responses. So like only last week there was a nice library published in the JS Weekly newsletter where you can like record the responses to your network requests. And that like builds up upon like a lot of practice from like Ruby community and the Elixir community, where we have like these VCRs. So effectively, the first time you make a request, the response to that request is being recorded, and the second time you make that request, it effectively reads from the store and gives you the same response. So that makes it easier to like re-record tests and record initial tests. But in our case, it still turned out to be quite painful because effectively you still need to update those tests and hit that like U button to update them. And it's not really nice because people didn't actually inspect what was changed, and like it wasn't easy to make sure that I'm testing the actual thing that I want to test. And the other annoying bit is that like the tests that aren't directly related would break, and that just like screams bad code if your like tests break that you haven't actually touched. So you want to make sure that the test is testing like the isolated bits. So as you've seen with the management pack component, we are like mocking the data that we want. We don't really care about everything else that changes in the backend. And all of the other data, if you change the shape of like the field or the other things that are returned that we don't really care about, it just like gets automatically filled with GraphQL tools mocks, and nothing breaks. So second bit, unit testing. In my head, I'm really old-fashioned. So in my head, unit testing is like testing a function and maybe like testing a shallow rendered component. And we don't have too many unit tests for the reasons I've mentioned before. Mainly with integration tests, you can cover a lot more ground, and we only use unit tests to cover branches that are very easy to test, very easy to cover with unit tests, and like you don't want to write integration tests for like every single branch. So there's actually so like as I've talked, calling a function and shallow rendering. Mounting for me is like an arbitrary line between when unit stops and the integration begins, because when you mount stuff, the components are the child components are actually rendered. You have side effects. You make network requests and you do all sorts of things. So mounting is the line where I'm saying like, okay, this is now integration is happening, and like I'm going to places, so I'm no longer contained to my unit. So if we go back to the management pack, we have unit tests for a management pack as well. And this is our unit tests. So effectively, the thing that you want to test with unit tests is like conditional branching. Albeit we've covered this already with integration tests, like we've tested some conditions and like some fields being rendered. We want to just like make double sure that like things are working fine. And since unit tests are very easy to write, we can just like do them. So effectively, we still mount with providers, albeit everything is happening synchronously here. And we mount that component and we provide the props ourselves. So we are no longer mounting all of the queries or anything like that. We just mount the React component. So if you have a look at this, we are mounting the management pack component, which is effectively just a function that gives you a value based on the arguments that you provided. So it's still unit testing, sort of. So we mount that function and we check that some fields exist and some fields don't exist. So we haven't actually written custom assertions for these. So we don't want to overdo with custom assertions, like littering them everywhere. for things that are very easy to test, like in this particular case, we just have regular just expression, just assertions. So yeah, we test every single possible condition. So when field has bits and pieces, if you want to make sure that like these fields exist, so like for every single scenario, we test that these fields should exist if this value is provided. The other field should exist if the other value is provided. So very straightforward. Nothing too fancy. Snapshot testing. Raise your hand if you have heard about snapshot testing before. Okay, a fair amount of people. So effectively, snapshot testing is testing strings. So you give the test a string. The test on the first run, it just like saves that string, and on the second run, it compares the newly generated string with the saved string and tells you whether the string has changed or not. That's snapshot testing in general. And snapshot testing was all the hype, and it was released by Jest, and like people really wanted to do a lot of snapshot tests. I was one of those people, so like I've had my code base littered with snapshot tests. I'm like I've been snapshot testing everything, and that didn't turn out so great. So all of my tests became really fragile, so painful, meaning that if I change something in the component and I've snapshotted my component, and I've changed the class, I didn't really want to test the class being there, but like if I change the class, my test breaks and I have to update it. If I change the order of things, or if I've like reordered something, I have to update my test. So everything I do, I have to update my test, meaning that it's just annoying. Like I don't want to keep hitting that U button every single time. So from the hype where like we've snapshot tested everything, we went to not snapshot testing anything, because like it's worthless. And like since then I've been like really looking for ways. So like what would be a good example for a snapshot test? What do we actually want to test with snapshots? Because like it's still a thing that people use, and I'm like I should find a use for it. So error messages, that's, or like any kind of messages that you have, are the things that I would test with snapshots. So for error messages, like the defining characteristics for me is that it saves you typing and copy time. So if you have huge error messages, you don't really want to manually type them out yourself and like make sure that it works fine and update it later on. It's very easy to inspect the snapshot. The message is very clear. It's very clear what changed, so that's cool. There still are cons to this. So it's hard to do TDD with snapshot testing. So effectively, you end up writing the implementation of it, and you can't get that like failing tests, and you have to store the snapshot and inspect the snapshot yourself. But the snapshot stored is fine. Readability is not great. So if you look at the tests, we have snapshot tests. This is a snapshot test. What does it tell you about the value that's being returned, or the value that I expect, or what do I want out of this? It doesn't really tell you anything. It's like to match a snapshot. So unless it breaks, I won't really get any value from this. And by reading this test, I can't really know what this error message is. With some extensions to VS Code, you can actually have a button that allows you to like quickly view the debug thing, but like not everybody has them. So in the team of multiple developers, it's unlikely that everyone will be able to like view this nicely. So readability is not awesome, and it's very easy to create fragile tests. So unless you're very disciplined with like only having it for error messages, our default is still don't snapshot test things unless you absolutely are sure that they will be the best way to test things. So again, I can, in my example, these are the error messages that I have for like custom matchers. So it's useful to have them with like snapshot tested, because like there's a lot of stuff that's being repeated about like async stuff not working fine. So when I refactor things and like move things around, snapshot tests really help, because they tell me this thing is broken, and like it's very easy to inspect them. Oops. So yeah, that's snapshot testing. And end-to-end testing, another beast. So end-to-end testing in my head is testing your app with everything. So browser, backend, third parties, basically all of your dependencies. You want to test everything as much as possible. And we use Cypress for it. So Cypress is a fairly new player in the market. I've used Protractor and Nightwatch before, and they have been good, but Cypress is better. So Cypress, why do I recommend Cypress? So it's minimal setup required to get started. So I remember the days when with Nightwatch, I'd have to like download the drivers that I wanted and like install them and make sure that like they're properly configured and all that stuff. Cypress just like basically works out of the box. You do yarn install Cypress and start yarn Cypress, and like it just starts. So it's really easy to get started. There's a clear consensus of the best way to write tests. So we're actually really good about writing guides as like how you should test things, how you should make shortcuts, how should you make your end-to-end test good. So even if you don't use Cypress, I'd recommend reading their guides about like end-to-end testing and how you should do it and what are the best practices in end-to-end testing. Tests are fairly fast. Like we are not as fast as integration tests because we obviously are running in a browser, but we are definitely faster compared to like my experiences with Protractor and Nightwatch. And finally, custom commands make tests easier to read and understand. So you probably already see a theme here. When I can write my custom commands, I can abstract a lot of boilerplate code that we need to write on every single test, and I can just say test this field, and it's very obvious to the reader as to what we are testing, and it's very easy to maintain and change things as we progress. The important bit to mention that I've skipped here, browser backend and third parties. In reality, what this means is since our frontend doesn't directly connect to any third parties, it usually goes through the backend as a proxy for like auth tokens, which we don't want to expose. It ends up being a one level deep end-to-end test, I suppose. So browser is tested, but like the backend, we only go to the backend and we mock third-party calls that backend makes. So we don't really want to make all of the calls because like the test can get really slow. So like with some of the third parties, like they can rate limit you, they can be slow to respond. So like your test will depend on them, which is not really nice. So as long as you mock the one level deep things, if you actually go the third party from your app, you should probably test this because that is important, and you're going to do that a lot from your live application, so you actually need to test this. But if you go through this through the backend, that means that as long as your backend works and things are fine with the backend, you don't really need to worry too much about third parties, because then it's backend's responsibility to test that all of the calls to third parties are working properly. So yeah, that's an important bit. Oops. Should have actually shown this while I was thinking about Cypress. But effectively, this is our test suite, and you can see how our tests are running. So on CI, we have like this video recording enabled. So you probably won't see too much, but there's like nice UI on the left that shows you all the running tests and like the loading apps. So even as you have tests on your CI, you can, if tests fail, you can see which tests failed. You can like view the whole thing and like watch a video. That's really convenient, but in practice, like it ends up being a lot of time where tests don't really break, and the video recording takes like 30 seconds or 1 minute to actually be created. So we just disabled it. But like at some point we used to have this. It was nice, but in practice it didn't like, prove useful. So yeah. Visual regression testing, that's another bit, and that's the last bit that I'll talk about today because I've already talked for a lot. So visual regression testing, who here knows what this thing is? Okay, a little bit less people. So visual regression is effectively testing the looks of the app. Again, it's like snapshot testing, except instead of snapshotting strings, you snapshot screenshots of your app. So you load your app or whatever medium you decide to like snapshot or screenshot, and you save that. So for us, there's a couple of things why we use these visual regression tests. So one thing is to prevent accidental changes. That does happen. So like you don't, then you say change the padding of a button and you add more padding to all of the buttons. It's really hard to say what actually will be affected by this on your site. Then you have visual regression tests. It's very easy to like see, okay, these are all the things that will be changed, and you can like approve or decline those changes. Second bit is easier to review PRs. So it's a really nice side effect of having visual regression tests in that if you change something visually, so like you add some CSS rules, it's really hard for people to inspect without actually mounting your app. So what ended up happening for us before is that like, oh, CSS looked good as long as things working fine for you. I'm confident that things are good. Whereas now what we can actually do is we can click on that actual snapshot and see what has been changed. How was the page affected? So you can very easily inspect the changes, and like if something looks fishy or like unintended, you can like point this out to the person. And for a person yourself, like when you ship those, it's really good. And the other bits being like very small things, like sometimes it catches weird things with like images being cached for too long, and you can like this test caught this, and some characters being converted to HTML entities. These sort of things are caught by these tests. So that was like a really nice side effect. So for visual regression tests, we use Chromatic and Storybook. Who has heard about Storybook? Raise your hand. Okay, so Storybook is like a very easy way to like start your app and effectively like showcase your components. So it allows for easy discoverability of the components for developers. And if you have it, which was the case for us, it's very easy to integrate with third-party tools. So Chromatic is a very new tool. It's so new that it didn't really have a good logo that I could put on a slideshow. So I just typed their name. I think they've just released their first real version this month, which you can pay for. So be there part of their alpha and beta testing program. And so far, like we are really happy with them. So why Chromatic? So there are three main criteria for us. Hosted third party. So again, developer time is really expensive. We didn't really want to have another testing type in our code base and having like maintaining a library and telling everyone how to use it. We didn't really want to do this. Features, so GitHub and Storybook integrations. So since we had Storybook already, it integrates nicely with Storybook, and I'll actually show it to you how it works, how easy the integration is. And multiple screen sizes. Since like we support 5 screen sizes for our sites, we want to make sure that we are snapshotting things on all of these different screen sizes. So if you look at the code, oh, I had some Cypress commands, but I forgot to show you. Yeah, so this line at the top is the only thing that we needed to do to get Chromatic working with our Storybook integration. So just like add one integration, and then in your CI, we had run visual tests. This bit. So effectively, yarn run Chromatic exit 0 on changes. This is a bit confusing, but effectively it means that if there are changes, break the build, as in make a notification on GitHub PRs. So it was very easy to integrate. For those of you who don't know about Storybook, I'll tell you a little bit about Storybook. Effectively, so Storybook, again, I'll repeat myself a little bit. It allows you to easily showcase components. So what we are doing here is we have .stories file near every component that we want to showcase. So again, we want to keep those files co-located with like components that we are showcasing. And with like a simple function, it creates a book. So let me show you that book. So this is our Storybook. It's a local version. So effectively just like shows all of the components that you have. Ooh. So you can easily discover the different types of components that we have at Nested and like see them. And Storybook just like integrates nicely with them and just like snapshots those components for us, and you don't really have to do too much work, which is nice. Let me get back into this. So yeah, there are some links. So it's very easy to get started with them. Like I'm not gonna spend too much time talking about that. And these are the nice things. Like this is the bit that shows up. Allow specs on change. Things are good. If something is changed, I can click on details and actually see what has changed. So this is what Chromatic gives you in that, like it shows you the changes. So in this case, you can see like that bug that happened with like this apostrophe being converted to an HTML entity. So yeah, these are all of our tools: Just an Enzyme, Cypress, and Chromatic with Storybook. Further reading if you want to. I'll probably share the slides with you, so you'll be able to click those links. You don't need to screenshot them. And that is it. Thank you.
Okay, thank you very much. It was pretty good.
Yeah,
thank you very much.
Yeah.
Do you have any question for David? Okay, cool. Hang on a sec.
Throw this around. Well,
Hello. Hi. My name is Faiz.
Hi.
Thank you for that presentation. It was really, really good, really insightful. One thing, I have a few questions, but I'll ask the others probably afterwards. But one of the main things, one question was, it, it looks like you had to think about the whole testing automation strategy quite deeply. Did you have a lot of pushback from other developers and other members of the team, and how did you handle that?
If the tests were painful, I had a lot of pushback. If the tests were very easy, as per Chromatic, like they don't really have to do much apart from what we are doing already. So like it's super easy. As for like integration tests, you've seen there's not much tests to write, and it actually speeds up their development because like we don't have to check if things are working nicely, like manually going onto the browser and like clicking that field and changing something and seeing if the mutation is fired. It was actually easier for them to write those tests than to like test that manually. So as soon as we made these tests painless, it became a very easy sell. When we were difficult, when we were painful, then yeah, I had to like say, oh, we need to write tests, and nobody really wanted to do them, and for a good reason. Like they didn't really give enough value for the effort that was spent writing those tests. So that's perfectly reasonable.
Okay, thanks.
Hi, my name is Fatih. Thank you for the presentation. I have two questions. The first one is, you mentioned components and demonstrated like some tools. Is it for testing only React applications, or if an application is written in Angular and it has components as such, does these tools are useful, or is it just for React apps only that these tools work?
So Jest and Runtime, as far as I know, they work for both Angular and React, and for Vue as well, I think. So like they try to be really open about them. And in general, like the principles here are that you need to isolate your components and make your tests painless, so that whatever testing tool you use, whatever setup you have, you want to make sure that for the effort that the person will spend writing those tests, it will be very easy to do that. So like the tools that you use are specific to us, but like they don't have to be your tools. Like there's a lot of tools out there. Use your own tools as long as you can like make your tests painless, man. It's fine.
Yeah, but if there are no components, if it is not Angular, it's just a
if your code is not good and like it's not isolated and it's like coupled with everything, it will be difficult to test. So like we had this problem in the beginning. So we went through a lot of iterations. So end-to-end tests with Cypress, we overdid it at the beginning. We had a lot of integration tests because we had a pattern that we started on that wasn't really helping us with our tests. So we had this like black box testing. We're just like, we went from the outside and we made assertions because everything else, like you couldn't mount a particular component on its own very easily. So in the beginning, we had this like end-to-end test everything. But now we are moving away from it, and like that allows us to like speed up the development. And it's like it's easier. With end-to-end tests, you can't really do test-driven development. So like you lose the first part, they're like you can ship things fast if you don't have like great feedback loop from your tests. So yeah, having good code and well isolated components, well isolated services, or whatever definitely helps with your tests.
Okay, and also how can we get the slides?
I can share them on Meetup or yeah, yeah. Follow JS community on Twitter and yeah, share.
Cool. Any other question?
Can I go? Hello. I wanted to ask you, do you follow any order when writing the tests? So do you do, for example, unit tests first and then end-to-end testing, or do you feel like the order of the testing is important or not at all?
So again, it's like very specific to each and every developer. The thing that I've noticed is that it depends on how good you are at writing tests. You may choose to write tests at a different stage. So in the beginning myself, like I didn't really have a good sense as to like what do I want to test and how do I want to test it. So I ended up writing the code, and I'm like, okay, now I'm trying to figure out how do I want to test this. As like my experience grew, I actually learned that like, okay, I'll want to create this component. So I already know what will be in that component. Like I've created hundreds of those components. I know what I want to test, so I immediately can write the test first. I usually start with integration tests because they actually give me a lot of bang for the buck, and they're the main things. And they usually test like the first flow. So like when you write a component, you don't usually like write all of the different conditional ways to do it first. You just like make thing appear on the page, right? So you write integration tests for that, and like that covers you. And then you want to add some like different flows, different conditionals, then you add usually unit tests because they are faster to write and they execute faster. So yeah, that's usually what I do. But again, it's up to every single person. Testing shouldn't be like a mandatory thing. If you feel that it makes you faster, then write tests.
How did you choose each technology or each platform to test? Like Cypress, for example. How did you get there?
Trial and error, I guess. Like just test every single thing. That try and use every single tool to see how it feels for you and for your team, for your company. For us, Cypress was like a natural fit because at the time we really needed to have good end-to-end test coverage, because like we had downtimes caused by things that could have been prevented had we like mounted our app and tested our build, but we didn't have it. So Cypress allowed us to like start things really quickly, and it was very easy for other people to pick up, even for like backend engineers that just like focus on backend. It was very intuitive for them to use, and that is why we stuck to Cypress. From my experience, like Protractor and Nightwatch, it's a pain to set up, and once you set it up, there's no good enforced way to write this. Bear in mind that I've used these tools like a year or two ago, so things may have changed. But like that was my experience.
Thanks.
Yeah, thank you. So yeah, my question is kind of related. Like, I understand that you did a number of iterations, and every time you were checking with the teams in terms of how does it feel, right? But all this time spent, you also had some sort of high level metrics that you were looking at. I don't know, team velocity if you were doing sprints, or number of downtime that you had in production, or I don't know, true positive versus false positive, like of test failures. Is there any metric that you were tracking to look like, also from a data perspective, like is this actually better? Or
so we don't really have like strict research. We research in terms like, is this type of testing better than like, is it better to unit test or integration test? We don't really have these sort of metrics. We are not big enough, and we are startup, so like we have features to ship, so we don't really have enough time to actually investigate things deeper. So like in many cases we have to go on things that like we've already done before, so we have experience, so like that feels right, I suppose. So like the only thing that is like a strict thing for us is like we have a downtime. So we want to have an uptime of I think 3 or 4 nines, and every week we have these incident reports. Like we have downtime postmortems when things go down, and we want to make sure that this never happens again. So if something happens a second time, that's like a big no-no, and we really need to fix this. And if it happens 3 times, then like shame on us. So these downtime postmortems are like things that always take a priority. So if our something went down, or like a page went down, or like a particular component wasn't usable, this always takes a priority. We investigate, why did this happen? What could have been done to prevent this? And usually it's like some sort of like testing that could have been done, and not that often human errors. So yeah, that's the only thing that we look at, downtime.
Yeah, sounds good.
Any other question?
Great. Thank you everyone for listening. It was really interesting to prepare this talk, and if you have any more questions, feel free to grab me later on. And
I was going to say, save your questions for a little later, and feel free to pop up to the 8th floor again for one more drink. And yeah, if you manage to catch up with the speaker once more, or amongst yourselves, yeah. So thank you very much.
Thank you, guys.